Your lines will be muted for the duration of this call. You can submit questions anytime during the call using the chat window on your ReadyTalk screen. We have a lot of material to cover today, so we're going to hold questions until the end of the call. And whatever you do, please do not put this call on hold. If you do, we might all hear your hold music, and nobody likes hold music. The slides from this call and the recording will be available with one day of the call. If you are a UTC member, then you can find them on UTC networks. If you are not a UTC member, contact me at the email address itot@utc.org. That's ITOT, like Information Technology, Operations Technology, itot@utc.org. Today we host both members and non-members of UTC on the call, and we have utilities and non-utilities on the call. Since we have some non-members on the call, I'm going to do a quick introduction to UTC for those of you who don't know us. UTC, or the Utilities Technology Council, is a global membership association, and we serve critical infrastructure providers, especially utilities, and their technology partners. We focus on collaboration among our members, advocacy for our members' best interest, and education to better enable our members to meet the coming challenges that utilities face. We want to make life better for our members, both utilities and their technology partners. If you are not a member of UTC and are interested in membership, please contact us via email at membership@utc.org. So that's all I've got. I'm going to advance the slide one more. And John Reno, it's all yours. Are you there, John?
Yes, I am. Thank you, Bob. Appreciate the introduction. So what I'd like to do is spend a little bit of time talking about the value of virtualization, and then we have several valuable insights planned for you around virtualization and NERC CIP. From Deloitte's side, we've got some great perspectives from both Tom and Joe around how those fit together and some of the issues and some recommendations. And then we'll hear a practical perspective from Steve, and then open it up to your questions. We've talked about who's participating. As I said, I'll focus on the value of virtualization. And virtualization applies really across our portfolio at Cisco and has had a broad impact in the industry over the last 10 to 15 years. And so it can take several forms in terms of physical infrastructure, virtual infrastructure, and cloud deployment, and spans a number of functions. Compute is perhaps the most well-known, but equally storage, security management, and network virtualization are all elements that combine to deliver agility, efficiency, and simplicity in terms of operation, policy implementation, and simply creating business value. So we often at a conference have several days worth of material on virtualization, and the Cisco product line itself has many aspects where virtualization comes into play. With IoT, perhaps the most evident application of virtualization is within fog computing, where we apply virtualization and the ability to execute applications on the network infrastructure. So edge routers, edge switches become a compute fabric for IoT applications and help solve problems of latency and data overload. Now, one of the first places that Cisco internally applied virtualization was for the problem of internal applications, and this goes back in history, really when the smart grid was was a concept and hadn't reached the implementation and scale that it had today. But quite simply, the experience of deploying a commercial or internal application was a very manual process where our teams rapidly would come up with the architecture of the application and how the system was going to be applied, code it, and then there was a quite manual process to figure out where physical infrastructure was available, getting the machines, installing the necessary operating system, and supporting environments, configuring it, securing it, and basically very much a waterfall approach. And today, and essentially for the last 10 years, we've had a really sort of simple value statement. We've taken the time to deploy applications from weeks and months to minutes. And so the process of deciding what to do and writing the code remains the same, but the process of drawing on compute storage and network resources are automated, self-serviced, and the provisioning happens within the virtualized infrastructure. And so that has several outputs that are important and provide real value to the business units as well as IT that's responsible for structuring the process. It results in capacity on demand, both scaling up and scaling down. So when you need compute, when you need storage, when you need network functionality, it's available. When the application is done or the testing has been completed, those resources are then freed up. Policy-based provisioning is also a key element. So the configuration steps, the access authorization to data, all that is automated and built into the process, as is governance. And so the overhead associated with internal, external applications has been significantly reduced. And so in terms of how we translate that into products and solutions and services that our customers can consume, we frame this as our digital network architecture. And so I used a simple example for shrinking the time from concept to production operation, which draws primarily on compute virtualization. But we have compute, network, and storage virtualization at the foundation of our product portfolio. And so today that means cloud-enabled, delivered as a service, and configured through software. Within the stack, there are a set of automation systems that carry out the role of policy control from the data center to the edge of the network, analytics that reside within the network to provide insights, and then management in the cloud from the ability to orchestrate multiple applications and control these elements by a centralized policy that's enforced in a distributed fashion. And so the net result that we bring with the digital network architecture is more rapid innovation, reduced total cost of ownership, and very importantly, lower risk. And so I'll touch on a specific example in the utility space, and this is interesting from the standpoint of adoption, because this was a pain point around applications that were distributed across remote locations, and so the business simply needed to build efficiency into their processes, and this took the form of slow service rollouts. These were the problems that needed to be alleviated, and so from that, the solution led to compute storage virtualization as well as network function virtualization for the infrastructure. Being able to draw upon virtual VPNs, virtual proxies, and having a standard method of managing this across the organization, whether it existed in a data center, a control center, or a remote location. And so that policy that then drove enforcement of authorization, authentication policies within the road infrastructure was essential to gaining the operational efficiencies that allowed this customer to deliver value, with compute storage network virtualization underlying that initiative. So there's an example of the system in practice, and with that, and to focus more on some of the trade-offs associated with NERC CIP, I'll hand it over to Tom Ulrich. Over to you, Tom.
Okay. Thanks, John. Bob, I don't have it doesn't look like I can advance the slides. Can you advance them for me? Okay, thank you.
Yep, sure does.
Okay. Virtualization has been around for more than 10 years in the IT environment, and there's no dispute that it can provide, back, please, Bob. Okay. There's no dispute it can provide huge benefits, both in lower costs and higher productivity. Beyond that, it can enable the business to provide more value to its customers than it otherwise could. But CIP versions 1 through 6 are silent on virtualization. Is it allowed? Is it not allowed? There's simply no answer to that question. Can you virtualize at all, given the current CIP standards? And if you can virtualize, how do you do it while remaining compliant? Now, many NERC entities have decided that the uncertainties regarding CIP make virtualization too risky to deploy in the OT environment, so they just don't do it. But some have gone ahead anyway, and later in this webcast, we'll hear from one entity that did this and what they learned from the experience. Next slide, Bob. Bob, next slide, please. Oh, I'm sorry. It is next slide, sorry. Okay. CIP versions 5 and 6 apply to cyber assets or programmable electronic devices. A virtual machine is software, and it's not a device, and that's what the fundamental problem is here. Does this mean an entity can implement VMs in the ESP without even worrying about CIP? I don't recommend that at all. But can you just treat VMs like bedside systems? If you do, you start to run into problems with some of the requirements which are written just for physical devices. Because of questions like this, many NERC entities have decided not to take a risk by not implementing virtualization at all. They're simply not going to do it. Now, this is one way of solving the CIP problem. However, it also means that entities can't take advantage of the increased productivity and lower costs of virtualization. Next slide, please. So what is the solution? Clearly, some of the CIP requirements and definitions need to be rewritten to accommodate virtualization. The standards drafting team is now working on this, but it will be 2 to 3 years before new standards are in place, that is CIP version 7. Meanwhile, NERC and the regions are encouraging entities to virtualize, but haven't provided much guidance on how to do this while still remaining CIP compliant. So Joe Andrews of Deloitte, former CIP auditor from WEC, will now discuss the NERC ERO's approach to virtualization and what it means for NERC entities. So here's Joe.
Good afternoon, everyone. My name is Joe Andrews. I'm a former NERC ERO member as recent as a month and a half ago. And some of the discussions that came up regarding entities wanting to implement virtualization within their CIP environments, some of the concerns and discussions that I was a part of dealt with mixed trust environments, managing VM cyber assets of disparate trust levels within a common virtual environment managed by a common hypervisor. And then the issue of mixed trust authentication, where a virtual machine has the capability to authenticate with Active Directory resources on a corporate environment, and then also having the ability to authenticate or access virtual assets within a CIP environment via two-factor authentication. There was also concerns about layered virtual architectures, entities maybe not understanding the full layered architecture and the interfaces of the components that make up their virtual environment. You've got, maybe your hypervisor, an internal virtual switch, you've got your virtual machines, and then maybe you have a device that's in that virtual environment in promiscuous mode that's actually managing all of those virtual machines. So where does logging, monitoring, and access controls, where's that enforced? How do you implement that and track it? And then there's the issue with baseline snapshots. Potentially you could, take a snap. We all know that, taking a snapshot of a virtual machine, it's a snapshot in time. So over the course of time, there's a possibility, a strong possibility that that snapshot is out of compliance because it's not receiving regular updates and security patches or configuration management. So with all the known unknowns, I can tell you now that virtualization is allowed. I've conducted multiple audits where entities have already implemented virtualization. However, there are certain important aspects of implementing virtualization within a NERC CIP environment, and I can tell you now that there can't be a mixed trust. You can't have a mixed trust environment, meaning you can't have a medium impacted bed cyber asset and a high impacted bed cyber asset within the same environment. Technically you can, but the high watermark concept is enforced, which means that the lowest impact rated cyber asset inherits the highest rated impact cyber asset within the same environment. So if you've got high, medium, or low cyber assets within the same virtual environment managed by the same hypervisor, then all of those cyber assets become high, and the high applicable security controls are applied to all of those virtual bed cyber assets. Then there's also the issue of the protection of the hypervisor and its associated virtual cyber assets. They all have to be protected, meaning that they all have to reside within an electronic security perimeter and be protected by an electronic access point. So that's the ingress-egress traffic to and from those virtual cyber assets, and then in case there's a requirement for interactive remote access, that would also have to be facilitated through the electronic access point and any supporting electronic access control and monitoring device, an EACMS device. And we also tell entities to ensure that virtual machines and their associated hypervisors are separately inventoried. We use when I worked for WEC, we used the NERC random sample methodology. So I would, sample your hardware assets along with your virtual assets, and we would audit the virtual assets, the same as we would the hardware-based cyber assets. So with all that said, I would recommend for a successful virtual adoption of virtualization within the NERC CIP environment, I tell you not to be deterred. The ERO actually supports innovation. I think the fact that there are a lot of known unknowns as it relates to virtualization, and the ERO, the NERC ERO, has allowed virtualization to happen, it's a prime example that they actually support innovation. On top of, direct, word of mouth that I've heard, they really don't want to stifle innovation because we, because we have those compliance issues that are unknown. I tell entities to work closely with their virtualization vendor support staff, communicate your compliance concerns and requirements. Oftentimes what happens is entities will go out, they'll implement, a solution and may not necessarily have all the information to identify the layered architecture and the interfaces that should, comply with the standard guidance. Also, I implore entities to ensure that their compliance staff are involved. Usually the SMEs are, the subject matter experts. They know firsthand how to implement the product. They know about the technical aspects of implementing the solution. However, the compliance staff are the folks that, have to identify and track the compliance components for every component of track the compliance requirements for every component of your infrastructure. So they have to be made aware of the security controls that need to be added to your compliance tracking program. I'd also tell entities to incorporate best virtualization security controls, and then also to inform the NERC ERO ahead of time. One thing you don't want to do is implement a solution and spend tons of money on a solution and find out that you can't implement it the same way that you would be able to in a corporate environment. This right here is a Visio diagram that I put together of the potential virtualization benefits within a NERC CIP environment. It's a high-level conceptual diagram. It's vendor agnostic. At the very top, I've got a primary control center, and then there's a virtual bedside system. And then adjacent to it, I've got a backup control center and a virtual bedside system there. And between the two facilities, there's an electronic access point. And what I'm depicting here is a live migration. So if need be, if there was a system failure or a system outage at the backup control center or the primary control center, you could live migrate a bedside system or a bedside asset, protected cyber asset in a matter of minutes over to one or the other facility. At the very bottom, I've got a virtual machine staging site where you've got virtual machines either in a suspended state or instantiated, waiting to be migrated to maybe your primary control center or your backup control center. In this scenario right here, imagine, if you will, maybe the primary control center goes out, right? And now the backup control center becomes the primary control center. But you want to add another layer of redundancy. So maybe you've got a standby site that has the required hardware and hypervisor and the associated APIs, and it's just a matter of live migrating the associated bedside system components within a matter of minutes or hours, and now you have a backup control center to your primary control center. So these are some of the inherent benefits of having a virtual environment. And I know, if someone who's, security conscious would say, it would be, it's important to have, the protection for that virtual machine staging site, even though it doesn't meet the criteria of NERC CIP, because maybe those devices, aren't really hooked up to the grid. But and I can tell you firsthand, I do reverse engineering and some malware analysis in my spare time, and it's a fairly trivial process to, even in a suspended state, to parse virtual machine images, and as easy as you could do like a netstat on a live running machine, you could parse the memory data structures to see what the running ports and services were at the time that the virtual machine was suspended. So Yeah, you definitely want to have adequate protection at that virtual machine staging site. But here are some of the benefits that you could imagine from a conceptual point of view. And I'll go ahead and turn it back over to Tom.
Yeah, here, sorry, I was on mute. So this screen shows Joe and my contact information. We'd be happy to hear any comments or questions you may have. The Deloitte U.S. firm has one of the largest, if not the largest, cybersecurity consulting organizations in the world. We have about 3,000 consultants. We work in all industries, especially power and utilities, and we do both general cyber projects like identity management, managed SIM, but also very specific NERC CIP projects. And in fact, we have over 100 consultants who have worked on NERC CIP. And we'd love to discuss any help we can provide your organization. Thank you, and I'll turn it back to Bob.
Okay, and all I have to do is introduce Steve Sumicrest of NIPSCO. And Steve, are you there?
Hi.
Yep, there you are. Cool.
Hi, I'm Steve Sumicrest. Like we introduced earlier, I'm the lead system engineer with Northern Indiana Public Service Company. Myself and my team and our counterparts all work to do the day-to-day real-time enforcement of the NERC CIP standards. So we live and breathe this every single day. We've been doing virtualization to some level in our high-impact sites since 2012. We're, for scope of CIP, pretty much 100% virtualized on the compute platform. We, as of recently in 2014, undertook the project to do some storage virtualization. We're also using network virtualization, and we're starting to dab our feet into some hyper-converged products, which kind of provide us some operational benefits to reduce complexity in our environments and some complexities with NERC CIP. In addition to the benefits we're going to talk about later regarding virtualization, the obvious elephant in the room is there's a huge reduction in floor print required when you do virtualization. We saw a 60% reduction in our SCADA environment by virtualizing, not even talking about the operational benefits that we've seen, which are the primary driving factor for us. So what I'd like to talk to you a little bit about today is what we've experienced going through a NERC CIP version 3 audit with virtualization, what we're planning on going through for our version 6 audit with virtualization, and where we plan on taking our high-impact sites with virtualization into the future. So I think it goes probably without saying, but one of the biggest things you need to do with your virtualization environment, especially in SCADA, is change control, planning, communication, working with the other business units, testing the software, knowing your environment. Virtualization is great for all the common benefits we all know about for consolidation and operational benefits. But it really comes down to, at the end of the day, you're running very important workloads on this system. And the typical driving factors for virtualization may not always apply here. Consolidation is great, but we need to make sure we're focusing on the primary driver being securing our control systems and providing a very reliable and robust platform for those systems and those applications to write on top of. And that's been one of the driving factors in all the designs we've put together for our systems. There's cost benefits by using virtualization, but by far our biggest benefit is we're able to control our assets much better. We're able to react to operational requirements much more agilely. And it's just provided us a really good way to move our systems into the future. But you need to do a lot of planning up front with these systems. It's not, the automation and the cloud and stuff are really awesome technologies. But you need to consider in your environment if this is the right direction for you to go, especially with automations, dynamic scaling up and down. You need to consider all of the security controls. You need to consider backup for all of those assets. You need to consider change control, having authorizations in place. This really shouldn't be an environment that you see a lot of dynamic up and down growth in your especially in your high-impact sites, which is primarily where we're focusing at. Knowing your environment is probably the second biggest thing you have to do before you really start heading down this path. You need to know what's the performance that your vendor is going to expect. What configurations do you need to know about? What ports and services? I mean, this is all required for SIP, but you really need to know what traffic is really going to be flowing through my environment. You need to involve your network and security teams and make sure they're aware of what traffic they're going to be pushing through here so they can properly tune their IDSs, so they can properly provision your firewalls, so they can be monitoring and assisting you to watch for those man-in-the-middle attacks or someone trying to get in the stream of virtual machine traffic, whether it's sitting on your box or whether it's in flight because of the motion or a live migration type of event. You need to consider everything, and when I say consider everything, I'm scoping it around your virtualization environment. Like Joe talked about a little bit earlier here, you need to consider all the components of your virtualization infrastructure. Now, your management consoles may often provide an interactive remote access path that you weren't expecting. And your vendors may not always be that helpful when it comes time to secure those environments. You know, I'd like the support tickets and whatnot you can work through, and you can get ports and services documented. But when you're implementing that, put it in a test environment. Know what is actually going on between that management console and your back-end infrastructure. You know, if you're opening a port that's going to allow you to get interactive remote access from a system that's not behind a two-factor gateway, you know, like a jump box or something, you may potentially have a violation there by missing an opportunity to secure an environment. Follow your vendor's best practices. They provide detailed instructions on how to harden your environment. Log everything. Make sure you're logging your performance. Make sure you're logging all of your access. Make sure you're logging all the changes. These systems are very verbose, and they provide a lot of good insight into what's going on in your environment. You don't want to lose that. Leverage your SIM, leverage your logging technologies to make sure you're capturing everything going on in your environment. And to help with some of the SIP controls, consider using TPM. A lot of these vendors now are supporting TPM modules, and we're able to make sure that configurations aren't changing at a hardware level. And it provides additional assurance to your auditing entities that you know what's going on and that you're doing what you can to make sure that your hardware and software that's operating your best cyber systems is as secure as possible, and you're meeting and obtaining the goal of the standard. You need to secure your environment. Virtualization is great, but it also opens doors to things you may not have thought of. Joe mentioned here a little earlier ago about bringing in dumps from memory as VMs are flying throughout the environment. Separate your traffic logically. Use network virtualization to separate out your management infrastructure. Separate out the back-end infrastructure for your virtualization. Separate out the storage path. Make sure that you make it as difficult as possible for people to get between these zones. Consider using layer 2 VLANs and don't put an SVI on them. Do you really, I mean, we talked earlier about moving VMs from one side to the other. Is that a business objective? If it's not, don't allow the routable protocol on the network. If the VM traffic can't leave the network, it can't escape and be used. You want to use automation tools to help with SIP10, your configuration monitoring. There are a lot of tools out there that will do this. We've internally written scripts for almost all of our best cyber assets to handle our configuration monitoring, and we do that religiously with the schedule in version 6. But it's also something we've done internally just to make sure we always know if our systems are drifting or not. Consider using scripts to do backups or snapshots of your systems before you're doing implementing a change via your change control process. Use it to increase or decrease memory or hard disk capacity or network changes or host changes. By scripting it out, you can take that script you deployed against the test environment, submit that with your change control, and push that against your production environment. And now you have a very good story to tell your auditor when you're doing your change control. We tested it in our test environment, and here's how we did it. And now we're going to take that and put it in our production environment, and we did the exact same task. Network teams have been doing this for years with their configuration with switch configs and router configs. This is new to some degree for especially Windows sites that haven't had the luxury of having text-based configs for a long time. But with the advent of PowerShell and a lot of other scripting utilities out there, Windows has quickly caught up, and all these other vendors have released Power Tools from Cisco and Power CLI from VMware. These tools help you to automate your systems and produce a very good and reliable audit-ready story about how you handle your change management and configuration management for these assets. And like I said at the very beginning, it's critical to test these systems. When we went through our vendor acceptance testing, we thought we had pulled everything. And as the environment grew, we quickly found that some of the technologies we were using were actually introducing some operational problems. Live migrations that are from any of the big vendors, for example, VMware vMotion, have to introduce some sort of stun operation. And SCADA applications, they don't like that very much. These applications have been written over decades and may not really know not know how to handle these kind of environments. So make sure you test it with your vendor, put it under load, make sure your operators know when you're going to test these things so they can be watching for oddities happening in the environment. And this goes back to knowing your environment. Make sure you understand what's going on behind the scenes, that you know that this traffic should be going from here to here, that you can baseline that, and you have ways to constantly reproduce that. I know what's going on in my environment. And lastly, be mean to your environment. When we went through testing, we were not nice to our equipment. We pulled plugs, we pulled fiber cables, we pulled network cables, we downed hosts, we introduced artificial memory consumption issues, we introduced CPU issues and contention. It's better to find this stuff out all before you put this environment into production and your operations team's calling you at 3 o'clock in the morning because they can't do their job. This is all common IT practice, but the OT teams are slowly adopting these technologies and may not have the expertise in-house to know about all these virtualization programs and techniques. So take the time to learn your environment, talk to the vendor, dig into what's really going on behind the scenes before you just rush this into an environment. And finally, be ready to defend it. Our auditors asked us all sorts of questions about our environment when we had our audit. Be ready, as Joe and them were talking about, be ready to show how your VMs map back to clusters and how those clusters are provided resources by hosts. Be ready to show how your storage backend, where that stuff's sitting at, how it interoperates with your environment. Make sure to know what your environment's doing. If you're confident about your environment, you're confident about all the components and how everything's working together, you'll have a very good story when your audit comes. And your auditors won't have that many questions for you. If you can show that you are securing the environment, that you're treating each VM as its own asset, that you're treating the hypervisor as an asset, that you're following the NERC glossary, and you're saying a host that is down is going to impact my BCA. It's going to be a BCA. When you're doing those things and you have good stories and you have good evidence to back that up, your auditors are going to trust you and believe that you're doing the right thing for the DOS. With that, I'm going to turn it back over to Bob.
Okay, thanks very much, Steve. And thanks, everybody. That was a super good session, and we nailed it on time. We've got 9 questions submitted so far, and we can help 10. Please keep them coming. I'm going to go back to the top, and I think this is for you, Joe. I was going to ask the same question. Can you elaborate a little bit more on mixed trust environments? I think one really confusing part of that environment or that question is, what exactly is an environment? How do you scope an environment? Is it physical? Is it logical? Is it both? And had you encountered any of those situations in your prior work as an auditor, if you're allowed to say that? So that's for you, Joe.
Yes, it's both. Usually, the compliance issues that are applicable to a traditional hardware environment are the same, compliance issues that would be relevant to a virtual environment. And really, it's the declaration of, if you've got, a BES cyber asset and its purpose is to, provide, resources for maybe, a high impact portion of the BES infrastructure, and then you have another virtual cyber asset, and its purpose, based on its functionality, is deemed to provide, medium impact services for, that portion of the grid. So we're saying that, it really is the risk inheritance, concept, in that, by its mere location, proximity to, a high impacted BES cyber asset, it should, the same controls, should be applied across, both BES cyber assets. And that's the same. So we have seen that. So you've got entities have implemented architectures where they just use layer 2 VLANs to separate networks of differing trust levels. So you can't have, you've got your protected electronic security perimeter, and then you've got maybe your corporate environment, or you've got a CIP environment of a lower impact category as identified, or by the entity, the registered entity. So a layer 2 switch is deemed not sufficient network separation for networks of differing trust levels, because you have things like VLAN hopping and everything like that, and trunking attacks. So we've deemed that layer 2 switches aren't considered, layer 2 VLAN separation is not considered adequate network separation. So in essence, you have a mixed trust environment. It's not considered proper network segmentation because of the inherent vulnerabilities of the layer 2 architecture, if that makes sense.
Okay, did any of the other speakers want to comment on that? I think you did a good job with it. Okay, sort of following on the same theme, Joe, I think you're going to get a few questions here. Sorry. And you can maybe see this on the screen as well. Even given full understanding of the no mixed trust and high water concept, can you do some of that with storage via, logical unit masking, LUN masking, to separate SIP versus non-SIP on the same storage array? Have you seen that? Is that something that'll work? I think
I'll tell you firsthand. I have seen some storage, with LUNs and storage virtualization implementations, and it really depends on the architecture. If you can make a case that and demonstrate within your network architecture that it's maybe systems to systems communications, and somehow the maybe the LUN, your storage area network, your virtual storage is somehow if your storage area network is within the electronic security perimeter, it's not a problem. But the issue that entities have is that they've spent tons of money on these storage area networks, and they want to leverage the resources to support their corporate environment and also the SIP environment. And in those cases, it's like you're abstracting, it's storage, right? It's a part of the trusted computing base of maybe a cyber asset that's in scope of the standards, and we're saying, all right, now we want to abstract it and have that exist outside of the electronic security perimeter, and it's really the communications between the storage area network and then your BES cyber asset. So there can be network separation, but it depends on the architecture. So I couldn't ask definitively unless I had an example of the potential implementation. But potentially it could happen, but there are caveats there. But the concern is that you can't have, generally you shouldn't have NERC CIP assets that reside outside of an electronic security perimeter without the proper network segmentation.
Okay. And then a sort of a related question, at what level in the system architecture can you mix trust, like medium versus high? Is that acceptable within a blade chassis or disparate compute nodes and hypervisor but sharing a backplane or a fabric?
Once again, it depends. When we're talking about networks and architectures of disparate trust levels, I mean, rule of thumb is that that those systems have to be, it's either they have to be totally separated. If there's going to be communications, just a backplane, that it has to be a backplane. If those systems need to communicate with each other and they're on a backplane, and that backplane, technically, if it has the ability to implement the access control and monitoring features of an electronic access point, if it's serving the purpose of the compliance requirements, then technically it would be allowed. I haven't seen that. Once again, it all depends. I'd have to look at the architecture, but rule of thumb, I mean, usually it's not allowed.
Okay. Joe, I'm sorry. It seems like a lot of people want your expert opinion here. But anybody else who wants to chime in, please just go for it. Another similar question. When it comes to capturing software as an asset, do we only have to do it for the items on the virtual machine, or also have to capture on the physical too? I think that's asking if you have to record it twice.
Okay, run that by me again.
Yeah, when it comes to capturing software as an asset, do we only have to capture it for the items on the virtual machine, or do we also have to capture it on the physical device as well?
Yes, so you have to inventory the physical device, its IP address, and any associated virtual machine instances. Those have to be, those virtual instances have to be inventoried and with their IP address, host name, and the whole nine, right? So, yeah, it's the host hypervisor machine, and then it's the associated virtual machines internally. Have to separately be inventoried.
Okay. Switching gears here, question about should all, Steve, I think you wanted to take this one on. Should all virtual machines on the EACMS hypervisor be categorized as the EACMSs?
So, yeah, I think this is going to be another it depends question, and it's going to depend on what acceptable risk your business wants to take. We include our hypervisors. This is our methodology. Again, this needs to be in your CIP2 methodology. You need to have this laid out how you're going to assess things. We've taken the approach that if you read through the standard, there's a clear definition about a BCA, and it's a set associated assets. We clearly believe that a BES cyber asset, a high-impact BES cyber asset running on a hypervisor, that hypervisor should be a high-impact BES cyber asset because there's classification in the glossary, there's wording in the glossary that say if this asset was unavailable, would it impact the ability to perform your job? One of the requirements for reliable operations. And it's clear, if you have a hypervisor, assuming you go down to a single point of failure system, which you have to for assessment, if you lose your hypervisor, you're going to lose those VMs on that box. The same's not true for EACMSs, PACs, and the other associations. Now, this is where it's going to differ on opinion. There's a very clear inclusion for hypervisors on the BES cyber asset side. It's not as clear on the EACMS side, and that's something your company and your CIP compliance program is going to have to decide what risk you want to take. Some companies may see that we want to include everything. We're going to make an EACMS cluster. We're going to make a PACS cluster. We're going to make an intermediate system cluster. That depends on how your interpretation of the CIP2 methodology is and how far you want to extend that. And that kind of comes down to every company's own interpretation, at least as far as we're concerned. So spend the time with your compliance folks, spend the time with your ERO, your auditing entities, make sure that your opinion matches up with those that are going to be coming in to talk to you.
Okay, thank you. This is one for anybody that wants to take it. How does vMotion impact compliance requirements for BCAs? By allowing virtual systems to dynamically move between locations, it seems that violates the boundary requirements of a documented ESP. Anybody?
Well, that's a loaded question.
Yeah, okay. Oh, that's why. I wondered if it was mute button issues. Okay, go ahead.
No.
I was speaking. Okay, sorry. I was on mute. Sorry. No, I laughed and I said I'll attack that as best I can. But that's one of those known unknowns, and that's definitely something that would. You're absolutely right. That would. I mean, with the way the standards are written right now, it would definitely have to. Maybe a live migration of a instantiated system would not occur, and it'd have to be a suspended state transfer. But yeah, you're absolutely right. Yeah, there are issues with compliance, and that's one that I cannot give you a definite answer right now. And I think even if you presented that to NERC CIP, I'm sorry, the NERC ERO, they'd tell you the same thing. They want to sidetrack it, and all 8 regions would get together, and they you're absolutely right. That would be an issue. That's one of those known unknowns. So sorry I couldn't answer your question.
Joe, this is Tom. I've got something to add there too, which is that NERC did put out a document at the end of the last year, which contained some advice on virtualization. And one thing they did point out is when you've got a farm where you can have VMs moving around all the different devices, you have to treat each VM as having the impact rating of each physical box as having the highest impact rating of any VM that could be migrated into it, even if it's not currently migrated. As long as there's a high VM that could at some point migrate into that box, then you have to treat it as high. And you would presumably have to treat all the other VMs there as high as well.
Yeah, and I think, it's John Reno, I think Steve had a good point, which is to look at the business drivers. And often vMotion and similar technology is of high value when consolidation is at a premium, and that is, as we recognize, is not necessarily a driver among the primary drivers of benefit for virtualization in the control center or utility environment.
Yeah, you certainly need to consider, your recovery point objectives here. If you are expecting that you're going to lose your primary control center and you need to have those services running at your secondary and they need to be available, within minutes, well, what happens if your network layer went down? Now, yes, there's technology to be mirroring the VMs over there, and that's another way to do it. Instead of vMotioning, have a copy of them being synchronized down there. It's another way to do it. We do that for some systems outside of scope for CIP. But are you really going to want to rely on vMotion getting your VM from the primary site to the DR site if you have an emergency? You just need to consider not just we can do that because we can. It's, well, do we really need that in the business, and is it an acceptable risk that we're willing to tolerate?
Okay, let's try another one here. Similar to using LUN masking on storage array, a Cisco UCF chassis has nodes, VCAs, and these nodes, there could be a guess that are VCAs and some that are not. And so it's responsibility of the entity to ensure that the SIP guests only connect to SIP vSwitches and non-SIP guests only connect to non-SIP distributed vSwitches, which requires trunking. How do you implement VLANs and stay compliant? Joe, are you on mute again?
Yeah, I am on mute, and I did not get that full.
Okay.
I'm sorry. That's a long one. It
is. I think the gist of the issue is if you're VLANing and you've got some SIP guests and some non-SIP guests, and you want to keep the SIP guests connected to SIP distributed vSwitches and the non-SIP guests connected to non-SIP distributed vSwitches, how do you do that with VLANs and stay compliant? And I'll see.
Once again, when you're talking about, SIP cyber assets, you're talking about critical infrastructure, and, there's a minimum standard of due care, and, you just really can't mix, when you're talking about cyber assets of disparate trust levels, you have to have proper network segmentation. And right now, throughout all of the 8 regions, what's considered proper network segmentation of cyber asset of disparate trust levels, it has to be an access point. It has to be a firewall. It has to, have access control rules. It can't be software based because of the known inherent vulnerabilities of that architecture. So oftentimes there's lots of things that you want to do, within your corporate environment, and that are, streamlined and they, improve your business processes and they're efficient, but there's just certain constraints with, that protected environment that just isn't allowed for compliance reasons. And it's, it's just not allowed.
Okay, thanks. Multitasking here. Okay, see if I can.
I saw one about there's a lot of talk about BES cyber assets and VMs, but what about EACMS and PACS? So for CIP5, if you look at the new definition, it deals with monitoring the electronic security perimeter and then also the BES cyber system. So if you internally within your virtual environment, if you've got a virtual asset that is monitoring the system's internal, to a BES cyber system, a virtual BES cyber system, in essence that device, it's placed in promiscuous mode and it's serving, the purpose of an EACMS device. All of the applicable security control requirements within CIP5 that relate to EACMS have to be applied to that component. So it's not just the perimeter. Now, there's, it's an issue of monitoring the BES cyber system. So it's the electronic security perimeter and the BES cyber system. So that would be an instance where you'd apply the applicable security controls to that virtual machine as an EACMS device. And for PACS devices, same thing. It would be security category rating inheritance. It would be the same issue there. You've got a PACS device. It sits on the same subnet as that BES cyber system. In essence, anything that resides on the same subnet as a BES cyber system inherits the security category rating of the BES cyber system. It's considered a protected cyber asset no matter what its designation is. Yeah, it's a PACS, but because it's also connected to the BES cyber system subnet, it has a dual designation as a protected cyber asset also, if that makes sense.
Okay, thanks.
And if it's external to the electronic security perimeter, it's out of scope.
Right, that's right. Okay, we're down to 1 minute left, and Steve, you wanted to say one more thing about islanding. Can you do that in about 48 seconds?
Sure. Yeah, I just wanted to respond to one quick question we had, or maybe comment about network islanding. I just wanted to clarify that we do islanding as a security mechanism to protect those that data in flight. We talked about being able to hijack, a vMotion, for example, occurring. We definitely want to make sure that have it islanded so that no one else can get into that network. It just removing a surface attack area is really what it's coming down to. It's not so much about CIP, not CIP. That network is certainly within scope for ESP and for monitoring, but we do it to abstract and just doesn't need a gateway, don't give it a gateway. It's about the least amount of stuff in your ESP as possible.
Oh, you did it. Okay, excellent. Thank you. All right, we are just at the top of the hour right now, and we still have about 8 or 9 questions we haven't answered, and I apologize, we're out of time. What I'll do is I'll make sure that the remaining questions are responded to and get those out to the people that asked for them. Again, I've had several questions during the time about the slides and the recording being available, and the answer to both is yes. If you are a member of UTC, you'll be able to find these on UTC networks. If you're not a member of UTC, well, first you should become a member of UTC, but then irregardless of that, you can contact me at the email address itot@utc.org, and I can give you the playback link for the recording and share the slides with you. They will be coming in a PDF format. So we're out of time. I thought the content was fantastic. Thank you to all 4 of our speakers. Thank you to Cisco and Deloitte for your sponsorship today. Shows a serious commitment to what is a really important and difficult problem to solve. This is not cookie cutter stuff. This is stuff where you need expertise. So thanks to everyone for your time. Thanks to all of you who are online. We're well over 100 people listening. And again, reach out to UTC if you need to. UTC members, you know how to find us. Non-members, either the email I just gave you or membership@utc.org. And with that, thank you, everyone, and this concludes our call.